So in this lecture, we will continue with the problems of solving non-homogeneous linear differential equations by the general method. So question: solve d2y by dx square plus dy by dx equal to 1 upon 1 plus e raised to x by general method. Solution: this differential equation can be written as d square y plus dy equal to 1 upon 1 plus e raised to x. Therefore d square plus dy is equal to 1 upon 1 plus e raised to x, which is of the form fd y equal to 1 upon 1 plus e raised to x. So here the auxiliary equation is fm equal to 0. This means that m square plus m is equal to 0, which I can factorize at m into m plus 1 equal to 0, and therefore m is 0 or m is minus 1. So once I have the roots of auxiliary equation, we can now write the complementary function. Therefore yc, which is called a complementary function, is c1 e raised to 0x plus c2 e raised to minus 1x, because these are the two real roots, and we know that the solution if the real roots are 0 and minus 1 is given by this. Therefore yc simplifies to c1 plus c2 e raised to minus x, because e raised to 0 is 1. So this is the complementary part. Now next, let us go to find what is the particular integral. So to find particular integral yp, it's called yp. Now we know what is the formula for the particular integral. Yp is equal to 1 upon fd phi of x. What is phi of x? Phi of x is the RHS. Which is equal to 1 upon fd. Fd was d square plus d. Phi of x is 1 upon 1 plus e raised to x. Okay, so once I reach this step, now what I have to do is I have to recall my formula of 1 upon d minus m. So I will do a rough work. What we know the formula is 1 upon d minus m phi of x is equal to e raised to mx integration e raised to minus mx phi x dx. Okay, so I know this formula for 1 upon d minus m. Now, how am I going to use the same formula for this current step? So what is the standard thing that you do? Firstly, you factorize the denominator. Firstly, you factorize the denominator. When you factorize the denominator, this will be the standard trick. Okay, this will be the standard thing that you have to do in all problems. Okay, factorize the denominator, which will be 1 upon d into d plus 1 1 upon 1 plus e raised to x. Okay, once you factorize the denominator, now you have two options. Now, what are the two options? Either you write the partial fractions a upon d plus b upon d. Do not write the step currently. Okay, copy only up to here. Either you write the partial fractions of 1 upon, you know what is the partial fraction of 1 upon x into x plus 1? It is a upon x plus b upon x plus 1. Okay, into 1 upon 1 plus e raised to x. Then separate, give this to this person, give this to this person, and then use this formula and solve it. This is one technique. But sometimes this technique may not help you. In that case, what is the other technique? I'm showing you both the techniques and then I will tell you which technique I'm going to use. Sometimes people look at it like this. It is 1 upon d into 1 up. This I have separated. Product I have separated. 1 upon d into 1 upon d plus 1 into 1 upon 1 plus e raised to x. This is saying that this is 1 upon d into 1 upon d plus 1 1 upon 1 plus e raised to x. And then I will solve this using the same formula again, the same above formula. Then I will find its answer, whatever the answer comes to be. When I completely solve this, I will get some answer. That answer is still stuck inside 1 upon d. Are you understanding this? This is like f composite g. What is f composite g? First you find what is gx. Once you find what is gx, then you apply f on that, right? Suppose I'm solving an double integration of some function. First I will integrate with respect to this variable. Suppose the variable is x, and then I will, whatever answer I will get, that answer I will integrate with respect to then y. This is how you do, right? So this is as good as integration. I told you that inverse operator is as good as an integration. So whatever answer you will get, then that answer I will operate 1 upon d. Now what? How will I solve 1 upon d? Again 1 upon d is 1 upon d minus 0, and the same formula is to be used. Okay. So now in this, for this particular problem, I am going to use the method of partial fractions. I'm going to write the partial fractions of the above. So now I know that what is a partial fraction of 1 upon x into x plus 1. This is your rough work, which is a upon x plus b upon x plus 1. Okay. So you put x equal to 0. I hope you know all the partial fraction techniques. So this is what I will follow. Put x equal to 0. So when I put x equal to 0, this will go away. I will not write a 0 in the denominator and I will get a 1 here. Right? And what will I get? I'll get the value of a. So the value of a is 1. If I put x equal to 1, x equal to minus 1, I will get 1 upon minus 1 into 0. I will not look at that, and for that you get the value of b. So the value of b is minus 1. So this is minus 1 and this is 1. So this is the partial fractions. Which is 1 upon d minus 0, 1 upon 1 plus e raised to x minus 1 upon d plus 1, 1 upon 1 plus e raised to x. Okay, so I'm erasing the partial fraction trick. And now how am I going to solve these two independent components, which is equal to, in this formula, if you put m equal to 0, you will understand that this becomes 1, this also becomes 1, and you just get integration. So what is 1 upon d? Basically 1 upon d is nothing but just integration, because this is 1 and this is 1, so you get integration of the function. So this means that this is integration of 1 upon 1 plus e raised to x dx. Okay, which I will see how to solve. Right? For this part, for the second part, the value of m is d plus 1 is 1 upon d plus 1. I have to compare with 1 upon d minus m. So value of m is minus 1. So put m equal to minus 1 in that formula, right? Plus 1 is minus m. So therefore m is equal to minus 1. So what is the value answer then? This minus e raised to minus x. I'm putting m equal to 1 in this formula. Integration e raised to x into phi x means right hand side 1 upon 1 plus e raised to x dx. Right? Now here I have to use my skill of integration. Now as far as this integration is concerned, as far as the second integration is concerned, this e raised to minus x is out of integration, so it has nothing to do with the question. And this is e raised to x upon 1 plus e raised to x dx. And this is 1 upon 1 plus e raised to x dx. Right? So there are various techniques by which you people do solve this particular two integrations. So how would this integration? This integration is pretty easy because you know that you can put 1 plus e raised to x. So once these two integrations are solved, my answer is over. Okay, you can put this as t. Therefore, when I differentiate, I will get e raised to x dx equal to dt. And therefore, the second part of integration is easy. E raised to minus x integration e raised to x into dx will become dt upon 1 plus e raised to x is equal to t. And integration dt by t is log t. So e raised to minus x log of t, but who was t? Who was t? T was 1 plus e raised to x. So the second integration is done. Okay. Now this technique of substituting integration 1 plus e raised to x equal to t will not work here because in the numerator I do not have e raised to x. So in that case, what I will do is I will multiply it by e raised. Now there are various techniques. You can use your own technique. The solution finally of all of us will be the same. When I multiply and divide by e raised to minus x, I will get e raised to minus x plus 1. Okay, and therefore what I will get is now I can put e raised to minus x plus 1 equal to t, and therefore minus e raised to minus x dx is dt. So this means that e raised to x minus x dx can be replaced by minus dt upon e raised to x plus 1 is nothing but e raised to minus x plus 1 is t, which is minus log t. But what is t? T is e raised to minus x, which is minus log e raised to minus x plus 1 minus okay. So this is the solution of, who was this? This was yp. So we have successfully done the integration. Now it may happen that some of you may use a different technique to solve this integration, and it may appear that you have got a different answer from what I have obtained, but the thing is that both the answers are the same. For instance, okay, well, so if I complete this solution, so what is the general? I'll come back to this in a minute. So therefore, what is the general solution? Therefore, the general solution is y equal to yc plus yp, and then you copy down both the things. You copy down what is yc, you copy down what is yp. This was a yp, and that becomes your final solution, right? Okay, so let us continue for the next problem. So question: solve the differential equation d square plus 5d plus 6y equal to e raised to minus 2x 6 squared x into 1 plus 2 tan x. Solution. So this is, so we will first look at the auxiliary equation. The auxiliary equation is fm equal to 0, which means m square plus 5m plus 6. So m is minus 2 and minus 3. So therefore the complementary function will become, so these are real roots, distinct. So c1 e raised to minus 2x plus c2 e raised to minus 3x. So after this, we will now find a particular integral. So let yp be particular integral. So fd yp is equal to 5x. This means yp is equal to 1 upon f of t phi of x. Therefore yp is equal to 1 upon f of t is d square plus phi d plus 6 into the right hand side is e raised to minus 2x sec square x into 1 plus 2 tan x. So as told you, after this you should immediately factorize ft. Once I factorize ft, I will write it as d plus 2 d plus 3 into e raised to minus 2x sec square x 1 plus 2 tan x. Now what I will do is, here I will note one important thing, is that I will write this d plus 2 factor after d plus 3, because you see here you have e raised to minus 2x. So I will shuffle the factor as d plus 3 into d plus 2 into e raised to minus 2x sec square x 1 plus 2 tan x. And now I know the formula of 1 upon d minus m phi of x is equal to e raised to mx integration e raised to minus mx phi of x dx. So here in this problem I will take 1 upon d plus 3 aside, and I will look at this particular factor 1 upon d plus 2 of e raised to minus 2x sec square x 1 plus 2 tan x, and here I will use m is equal to how much? So what is the value of m here? So d plus 2 is compared with d minus m, so this means m is minus 2. So here m is minus 2. This means which is equal to 1 upon d plus 3 into bracket e raised to, I'm using this formula for m equal to minus 2, e raised to minus 2x integration e raised to plus 2x into phi of x. What is phi of x? E raised to minus 2x into sec square x 1 plus 2 tan x dx. So this is the reason to cancel this e raised to minus 2x and e raised to 2x. I shifted these factors in this particular way. I hope now you understand. Now after making a practice of such type of sums, you will understand which factor to take first and which factor to take the next one. So I'm left with 1 upon d plus 2. Outside the integration, you have e raised to minus, d plus 3, yeah. E raised to minus 2x, then integration of sec square x into 1 plus 2 tan x dx. Now this is easy because I can just put tan x equal to t, and therefore sec square x dx will become dt. So sec square x into dx, this will be replaced by just dt. So we will be left with 1 upon d plus 3 e raised to minus 2x dt instead of sec square x dx, and 1 plus 2 tan x will become 1 plus 2 t. When I integrate 1 plus 2t, I'm going to get 1 upon d plus 3 e raised to minus 2x. Integration of 1 is t, 2t is t square by 2, 2 gets cancelled. So I'll get t plus t square. 2t square by 2 has cancelled. But what was t? T was tan x. So it is 1 upon d plus 3 e raised to minus 2x tan x plus tan square x. Now I will apply here the formula for m equal to minus 3. What is the formula? I will write the formula here. 1 upon d minus m phi x is equal to e raised to mx integration e raised to minus mx phi x dx, which is equal to e raised to minus 3x, because m is minus 3, integration e raised to plus 3x into phi x. Who is phi x? This entire person is here. Phi x e raised to minus 2x tan x plus tan square x dx. Okay, so and just erase the annotations now. Fine. So this will be equal to e raised to minus 3x integration e raised to x into tan x plus tan square x dx. Okay, so the time comes that now I must know how to integrate this particular person, but I know that tan square can be replaced by sec squared minus 1. If you really observe, the length of the sum is pretty big. The sum is becoming very lengthy, but it is not very difficult. Sec squared minus 1 dx. So once I have tan x in the picture and sec square x in the picture, I know that tan x has derivative sec square x. I will now do what? I will organize the terms a little bit. Because there is an e raised to x outside, see carefully, it is e raised to x. What I will do here is tan x minus 1 plus sec square x, which is now looking in the format of our well-known formula e raised to x f plus the derivative. The derivative of tan x minus 1 is sec square. This is the reason I took this 1 inside the bracket, because the derivative of 1 is going to be 0. So this will be f plus f dash. And what is the formula for who is f here? F is tan x minus 1. And what is the answer for this integration? It is e raised to x into f, which is equal to e raised to minus 3x into this. So it is e raised to minus 2x into f. Who was f? It is tan x minus 1. So finally we are rid of entire integration, and we have got, this is your yp, and therefore your general solution is y, which is yc plus yp, has become y equal to c1 e power minus 2x. What was the complementary function? The complementary function was c1 e raised to minus 2x plus c2 e raised to minus 3x plus e raised to minus 2x into tan x minus 1. So this is a very lengthy. Okay, let us take the next question. d2y by dx square minus dy by dx minus 2y equal to 2 log x plus 1 upon x plus 1 upon x square. Solution. This is d square minus d minus 2y equal to 2 log x plus 1 over x plus 1 over x square. which is FD. So the auxiliary equation is Fm equal to 0. So this means that m square minus m plus minus 2 is 0, which is m minus 2 into m plus 1. So m is equal to 2n minus 1. So this means that the complementary function is c1 e raised to 2x plus c2 e raised to minus x. So f d by p for yp is equal to phi of x. So yp is 1 upon ft phi of x, which is equal to 1 upon d squared minus d minus 2 phi of x. What is phi of x? Phi of x is 2 log x plus 1 upon x plus 1 upon x square. Factorize phi of x, which is d minus 2 into d plus 1, 2 log x plus 1 over x plus 1 over x square. Now here again a question comes that should I write it d minus 2 into d plus 1, or should I write it as d plus 1 into d minus? Should I shift them or should I not shift them? Now we know that d plus 1, 1 upon d plus 1 means m is minus 1. So this means that if I'm having m is equal to minus 1, the formula says that it is e raised to mx into e raised to minus mx into something phi of x. So this means that if I put m equal to minus 1 here, this will be that e raised to minus x into e raised to x. So it will give me e raised to x inside the integration, and which will be helpful for me to solve when I multiply e raised to x to this type of integration. So I will keep this factor as it is, d minus 2, 1 upon d plus 1 into this 2 log x plus 1 upon x plus 1 upon x square, which is equal to 1 upon d minus 2 e raised to minus mx. I'm using m equal to minus 1, e raised to minus mx, e raised to minus 1x integration e raised to x into 2 log x plus 1 upon x plus 1 upon x square. Okay, now here I have to again think dx. Now here I have to think of that this I have to fit, this must fit in this fashion of e raised to x f plus f dash. Now who is the derivative of which particular person, so that these three terms might get adjusted. The thing is that if I take f is 2 log x, the derivative of 2 log x will become 2 upon x. So for 2 log x, I am going to need a term as 2 upon x, correct? So I should do one thing, that I should add 2 upon x in this particular bracket, so that my 2 log x derivative 2x 2 upon x will get adjusted. Means what? Which is 1 upon d minus 2 into e raised to minus x e raised to x into 2 log x. For 2 log x, I must have 2 upon x, right? And this 2 upon x, when I subtract minus 1 upon x, it will become minus 1 upon x. So eventually this term is nothing but 1 upon x. So the meaning of the above two, the bracket terms simplified to be equal, but I have adjusted what? 2 upon x. And therefore what has happened is that when I collect the two things together, which two things together, automatically do you see some very big adjustment is done. This means that e raised to x into 2 log x minus 1 upon x. This is f, and what is the derivative? The derivative of 2 log x is 2 upon x, and minus 1 upon x, the derivative will be plus 1 upon x square. Automatically all the 4 terms have been now adjusted, and now this perfectly looks in the form of e raised to x f plus f dash. Now we can use our integration e raised to x f plus f dash dx. So this is your f, which is equal to 1 upon d minus 2 e raised to minus x into the derivative. The integration is e raised to x into f. What is f? F is 2 log x minus 1 over x. So this cancels, and now last step, I'm left with this 1 upon d minus 2 of 2 log x minus 1 over x. So I'm going to use m equal to 2 now. We know the formula is e raised to mx integration e raised to minus mx fx phi x dx. So m is 2, which is e raised to 2x integration e raised to minus 2x into 2 log x minus 1 over x dx. Now I have to worry how to solve this type of integration. So first of all, let me separate them out. It is e raised to 2x integration of e raised to minus 2x into 2 log x minus integration of e raised to minus 2x into 1 upon x dx. Okay, now if I look at this particular term e raised to minus 2x and 1 upon x, we know that the derivative of e raised to minus 2x will be minus 2 e raised to minus 2x plus 4 e raised to minus 2x and so on. So it will always e raised to 2x minus 2x will always remain with some constant. My 4 will become minus 8 and so on. So that 2 will go on multiplying. So this derivative, when I go on taking many derivatives of this particular person, this will never become 0. So it will not be easy to here this is one problem. But what about 1 upon x? What are the derivatives of 1 upon x? The derivative of 1 upon x is minus 1 over x square, and then plus 1 upon x raised to minus 3 minus 4, and these powers will go on increasing, right? Because this will become x raised to minus 2, and when you integrate this thing, the derivatives will go on decreasing, and find the thing is that this will never become 0. This particular person will never become 0, and that is the reason I cannot use here by parts, right? When do you use by parts? Usually, when you use by parts, one of the person in the product is becoming 0. Otherwise, the by parts will never stop. So here the by parts never stops. Here by parts, integration by parts will never stop. So I will not do the second integration by parts. Okay, but let me try for this one. I will do only one step for this by parts thing. So what is that? E raised to 2x. 2 I will take outside integration. This is u and this is v. u integral of v. U is log x. Integration of v is e raised to minus 2x upon minus 2 minus integration of, take u dash and multiply with integration of v. What is u dash? Log of the derivative of log is 1 over x. 2 I have taken common, so 1 upon x into integration of v. Integration of v is e raised to minus 2x upon minus 2. This 2 is a common bus. So let us multiply that 2 inside to both of them now. So this 2 will multiply here also, and this 2 will multiply here also. Minus, the last integration is as it is, e raised to minus 2x into 1 upon x dx. What has happened because of this is that this 2 will cancel. This 2 and 2 is also getting cancelled. Eventually I've got log x e raised to minus 2x with the minus sign. This has become plus. This minus and this minus has become plus integration e raised to minus 2x into 1 upon x minus integration e raised to minus 2x into 1 upon x. And this integrations have cancelled each other. Sum now. Here auxiliary equation is fm equal to 0. So m square minus 1 is 0. So m is 1 and minus 1. So yc c1 e power x plus c2 e power minus x. For yp, f d yp equal to phi of x. So yp will become 1 over fd phi of x. Therefore yp is equal to 1 over d square minus 1. Phi of x is e raised to minus x. Sine of e raised to minus x plus cos of e raised to minus x. Therefore, I will factorize the denominator, which is 1 upon d plus 1 into d minus 1 of e raised to minus x sine of e raised to minus x plus cos e raised to minus x. Therefore, yp is 1 upon d plus 1 into 1 upon d minus 1 of this plus cos e raised to minus x. Now when I recall my formula of 1 upon d minus m phi of x, it is e raised to mx integration e raised to minus mx phi of x right? So here, this means that if I take m equal to 1, if I put m equal to 1, what will happen? So this might become e raised to 1x integration e raised to minus x into phi of x. This is a phi of x. E raised to minus x sine of something plus cos of something. And in this case, I may not be able to use the formula e raised to x f plus f dash, because this is looking like sine and its derivative is what? Its derivative is cos into this, right? So here I may face a problem of having that e raised to x is not there inside. This is the reason this d minus 1 I cannot take, I cannot use this d minus 1 for solving this component. So it is not a good choice. So that because if I take d minus 1, I'm going to get a e raised to minus x. So knowing all the troubles that are going to come in future, I will smartly swap the two operators. I will say d minus 1 into d plus 1. This is done. I've swapped them. I hope you understand why I've swapped them, so that my integration will become easy in the next step, which is e raised to minus x sine of e raised to minus x plus cos of e raised to minus x. Now if I use the formula m equal to minus 1, this will become 1 upon d minus 1 into e raised to minus x, e raised to mx. M is how much? M is minus 1. Integration e raised to minus mx. So it will become just x into the entire function. What is that function? Now here again I'm going to use a little bit smartness. I'm going to write this first and this second. Cos e raised to minus x plus e raised to minus x sine of e raised to minus x. Why? Why am I doing this? Because I know this is a function and I know that this is the, what is the derivative of cos e raised to minus x? It is minus sine e raised to minus x into minus of e raised to minus x. So that will become plus. So this is the derivative of that function, and this is e raised to x into this. And what is the derivative? What is the integration of e raised to x f into f plus f dash? This e raised to x f, which is 1 upon d minus 1 e power x into e power minus x into e power x f. So we have 1 upon d minus 1 into f. Who is f? F is cos e raised to minus x, which is 1 upon d minus 1 of cos, not cos, not cos. Yes, correct, it is cos. Cos e raised to minus x. And put m equal to 1 in the formula. So it is e raised to 1x integration e raised to minus x into function. The function is cos e raised to minus x dx. Okay, I hope I'm clear up to here, and I have possibly made no mistake. Okay. And what is the, how will I solve this particular type of integration? I know that I can put e raised to x is occurring twice. So why don't I substitute e raised to minus x equal to t? And so if I do that, I'll get minus e raised to minus x dx will become dt. Correct. So this eventually means that e raised to x is as it is in the integration e raised to x into dx. This product can be replaced by minus dt and this will become cos t, correct? So this will become minus e raised to x integral of cos t dt, which is sin t, which is minus e raised to x sin t. But what is t? What is t? T is e raised to minus x. So it is minus e raised to x sine e raised to minus x. So this becomes your particular integral, and therefore the general solution will become y equal to yc plus yp.